Hai, selamat sejahtera. Hello, everyone. Welcome to our Magic Revision channel, slot 4, the final paper, SK025, Chemistry 2. So how are you today? Okay, so today we are going to welcome our two speakers, Madam Chia Peng. Say hi to everyone. And also Madam Tang. Okay, so because it's already 9:30, I hope that you have complete your prayer. And also we are going to start our section for today's. Okay, so without wasting the time, so we are going to start with the physical chemistry by Madam Chia and also the organic chemistry by Madam Tang. Before we're going to start, okay, so could you please take a look? There is a link in the chat, live chat. Okay, the link is the Telegram link. If you have any question or maybe today's or the material and slide, we will post over there. So you can try to click, and also do not forget to subscribe our channel. So any updated information will be updated over there. Okay. So, and by the end, if you have any question, you may drop your question in your live chat box, and then we will give the Q&A section after the two slot finish. So are you ready with it? Okay, so if you're ready with it, now we are going to start with, okay, we are going to start with the Madam Chia. Okay, so here we go.
All right, okay. Good evening for all students. So my name is Madam Chan. So tonight I will share with you about the physical chemistry. So now we have a look about the for SK025 divided by two parts. First one is a three question for physical chemistry, and another part is organic chemistry, right? So now we overview about the topic physical chemistry, where is reaction kinetic course 11 marks, locate for 11 marks, thermochemistry 11, and electrochemistry is 8 marks. So today I will more focus to thermochemistry and then a little bit about the electrolysis, electrochemistry. So this is chapter 1. So after the section, right, I will left the PowerPoint slide in the Telegram group so you can overview the reaction kinetics. So I straight away go to the thermochemistry. Right, so thermochemistry, right, is all about its application about definition. Okay, so before we start about the discussion, right, so we try to connect the definition. Okay, the first one is 1 mole of the compound, formed by is element, so in more stable state. So the element is referred to the any acid in the world like Cl2 gas, H2 gas, and S solid. So this is called enthalpy of the formation. Okay, so next I go to this one, number 3. 1 mole of substance react with oxygen. So you know, you react oxygen mass enthalpy of combustion, right? Okay, so the answer is enthalpy of combustion. All right, next we go to this one. This one I think you're familiar. So acid and base will produce a salt and left one thing. Salt and 1 mole of H2O, 1 mole water. So definition refer to this one refer to 1 mole water is refer to the enthalpy of neutralization. All right, next one, the 1 mole of atom gases formed by its element. Example is Na solid, you form the Na gas atom. So gaseous atom, so this is the enthalpy of the atomization. Okay, why I left these two is why is answer for solution and hydration. Now, the first one is 1 mole substance dissolved in the water to form the ion in aqueous. Let's say you dissolve a salt and NaCl solid. So after then you form the Na plus aqueous and Cl minus aqueous. This is a stand for the solution. Okay, macam you larutkan garam dalam air. So larutan garam macam di solution. Okay, next one, 1 mole of ion gases to form the ion in the aqueous. This one we call enthalpy of hydration. Because today always confuse solution and hydration. Solution is referred to the the salt dissolved in the water. Hydration is a gaseous ion to form the aqueous ion. So the difference is here. So in the definition, you can see I highlight 1, 1, 1. Why I highlight 1? Because the definition refers to the 1 mole for compound or substance or water. So when you study revision, right, you must make sure you understand where is the 1 mole they emphasize. Okay, so because this one help you to solve the problem. All right, now for thermochemistry, I try to summarize with few parts. First one is okay, let's say you will see combustion, formation, enthalpy, other, right? Usually they will ask about Hess's law, calculation involves stoichiometry, or the formula involve the formation and the reaction. Okay, the first example is standard enthalpy combustion for ethane is negative 1411. So this is called delta H reaction. Giving the following standard enthalpy of formation, meaning that this is called enthalpy of formation. Calculate the standard enthalpy formation of C2H4. So that means the question asks about enthalpy formation of C2H4. All right, so this style of question contain reaction and formation, right? Actually, we can apply the formula. So before apply formula, we must write the complete equation. For thermochemistry, equation must balance and with the phase together. They very emphasize. So this is an equation where the complete combustion produce 2 more CO2 and 2 H2O. So what's the information they give you is they give you delta H reaction for the reaction. Then they give you delta H formation for CO2. They give you delta H formation for H2O. Then they ask why is a delta H formation of C2H4. So this kind of the case, right? So it means why is a delta H formation for C2H4? We'll apply the formula. Okay, so the formula is a delta H reaction equals to N is number of mole, delta H formation product minus M is number of mole of delta H formation of the reactant. Okay, so now I will write the formula. Delta H reaction equals to 2. Okay, why I say 2? Because here is a 2 mole. Delta H formation CO2 and then 2 more, then this is a 2 delta H formation H2O, where is this is a refer to the product minus reactant. So this is a refer to the reactant. Since reactant is a 1 more, so here is a 1 more delta H formation C2H4 and 3 more delta H formation O2. All right, so now we substitute the value here. Yeah, so now I substitute value. But why suddenly the oxygen I label 0? Okay, so students, if they didn't give you the delta H formation, right, that means it's a 0. Let's say example, the element in the most stable state, right? So it's a 0 delta H formation. Example, O2 gas, Cl2 gas, H2 gas, nitrogen gas, and air solid, magnesium solid, where is the exist in the natural condition. So it's a 0. So I don't know delta H formation for C2H4. Then now I can find the answer. So I can find the answer 40.4 kilojoule per mole. So since the question is referred to specific name formation, so I'll give the answer with the unit kilojoule per mole. Okay, so this is one of method by using the formula. If a student don't want using formula, they can construct the like Hess's law also can. Okay, now we proceed to next question. Okay, next question is they give you 3 equation. So then calculate the delta H reaction for ethylene with F2. So this one, right? This type of equation is this is a 3 equation, 1, 2, 3, and this the equation that one. So this one you call target, and this 3 equation is we must arrange to get the target. So this one we can apply the Hess's law to solve the problem. So Hess's law question, right? They maybe they give you 3 equation, or maybe they give you 4 equation, or maybe 5, we don't know. And target, right? Sometimes they give you the target already. Sometimes they maybe define the target is enthalpy combustion of C2H4. So students need to write your own target equation. So this is challenging for Hess's law. Okay, now, so we solve the Hess's law. Hess's law divided by two methods. First one is algebraic method. Second one is the energy cycle method. So if the question didn't mention any method, right, so you just solve the problem by using algebraic method, unless they mention by using energy cycle method. Not all questions can use energy cycle method because energy cycle method is usually using for the simple equation. All right, come. First, now we try to solve the algebra method. Okay, now first one, I will find the reactant C2H4. So the target is 1 mole, and on your reactant side. Okay, now you can check C2H4 here is on your product. So how to product to change become reactant, right? Meaning that you need to reverse the equation. I say class, now I reverse the equation. Okay, so I reverse the equation. C2H4 gas. Make sure you copy all the equation with the phase together and all the information. Okay, so your delta H can label delta H1. So this is a positive. Once you reverse, they become negative. Or if a negative reverse, you become the positive. So 52.3 kilojoule enough. Okay, so we settle the first reactant. Now we focus to 6F2. Okay, class, you can see here, for the F2, right, it's how many times, okay, wait. So how many times axis F2 is here, F2, and second, 2F2. So if the question, the substance exists 2 times and above, right, usually I will ignore first, I KIV first. Saya letak sebelah dulu, nanti baru selesai. Because, right, if it exists 2 times, right, usually they got a different probability. So sometimes the idea you come out is not the exact answer. So better we KIV first. So you focus to the substance yang exist 1 time, wujud sekali sahaja. Let's say CF4. Okay, so CF4 exists 1 time. So this is on your product side. This is also product side. Okay, no problem. So now this is a 2 more. So I need to times 2. So now I times 2 for the equation. So 2 carbon solid plus 4F2 gas, then produce the 2CF4 gas, and delta H2 equals to negative 680 kilojoule times 2. Okay, now settle the CF4. Now I focus to HF. Here is a 4 mole, but here is a 2 mole, and at the same product side. Meaning that to make it 4 mole, the equation must times 2. Once times 2, all equation must times 2. So the answer will become the 2H2 gas and plus the 2F2 gas and form the 4HF gas. And you can label delta H3 is a negative 537 kilojoule times 2. So then we draw the line. Okay, class. Now you try to make it like parallel the arrow so that wait for the careless mistake. Now the concept now is left and right side you can combine. Right and right you can combine together. Left and right you can minus. Okay, now we check. Okay, 2 carbon, 2 more carbon cancel. 2H2, 2H2 cancel. Okay, no more. Now we summarize the reactant part. So C2H4 gas plus, okay, you can see here, 4 plus 2 equals to 6F2 gas. So 2CF4 gas and plus the 4HF gas. All right, class, you can see my F2 where is auto parking already. Automatically you get the 6F2, right? So this is a tips or hints how to solve the things like exist more time. All right, okay, so we achieve. So how you get the mark, right? Actually, the mark is very strict. So here, you must give me the complete one until delta H, you get 1 mark and so on. So to solve the problem, you can solve like delta H reaction equals to delta H1 plus delta H2 plus delta H3, where is a Hess's law. So you can summarize and you get the answer delta H. So the answer I get is a negative 2486.3 kilojoule. Because the question just mentioned reaction, so we just left answer kilojoule. Make sure the sign positive negatives must write properly. Okay, so this is tips for Hess's law. Now we proceed to next part is calorimeter. So usually calorimeter, right, is referred to the two Born-Haber and coffee cup. Born-Haber usually discuss about enthalpy combustion because it involves the burning process, and coffee cup calorimeter involves a neutralization or solution or hydration. Okay, now general concept you must know. As you know, the heat cannot be destroyed. They only can be transferred. So once the combustion happens, how the heat transfer? Okay, now we look at the answer. So once the heat release the heat, right? So release the heat, right? So surrounding is water. And calorimeter contain the heat capacity and the water contain the mass. So once the heat released by the reaction, two things will absorb the heat is a mass of water and heat calorimeter, because they contain the heat capacity. So the first formula is the heat released by reaction equals to heat absorbed by water and absorbed by calorimeter. So if the question without any information about heat capacity or didn't ask or didn't give anything, so that means you assume heat released by reaction is equal to heat absorbed by water. Let's say case number 2 is they didn't mention mass of water or didn't ask about mass of water. So we just assume mass heat released by reaction is equal to heat absorbed by calorimeter. So this concept for bomb calorimeter. Now look at the coffee cup calorimeter. For coffee cup calorimeter, right? So usually involve the acid and base. Let's say 100 ml acid. Let's say 100 ml for sodium hydroxide. The mean solution now actually is a 200 ml equals to 200 gram. So this is a mass of solution. Alright, okay, so this is experiment 2. During the acid and base react, right, actually they will release the heat. Okay, so you know, right, heat cannot be destroyed, heat only can be transferred. So who will absorb the heat? Yes, the answer is solution will absorb the heat. Second one is calorimeter will absorb the heat because they give you the heat capacity. So general formula is a heat released by reaction equals to heat absorbed by solution plus heat absorbed by calorimeter. Let's say the question didn't give you heat capacity, so that means that heat released by reaction equals to heat absorbed by solution. So student, when you study this question, you must make sure understand how the heat transfer and how the heat flow. Alright, now we continue with a different case. So I try to divide the question in two general parts where is student easy make the careless. The first one is they giving you experiment data, they ask about theory. So what is meaning by this? So student, when you go through the question, you must understand what happened and what they give you and what they ask you. Now, a boiling calorimeter contains 780 gram water and amount of 3.4 gram benzoic acid is burned. That means that this is your experiment data. So maksudnya, you can change to the mole. You can change to the mole, then you can get the heat. Then, this is what they given. What they ask is a heat involved per mole of benzoic acid, meaning that they burn 1 mole. How many energy release? Okay, so you can see they give you data. Okay, I burn X mole. I know how many heat. Now they ask if I burn 1 mole, how many heat? So they will exchange in terms of experiment or theory. Okay, second case is this one. They give you theory, they ask experiment data. Okay, the enthalpy of combustion of benzoic acid is negative 3226.7, meaning that they burn 1 mole. They burn 1 mole benzoic acid, you release 3226.7 kilojoules. So this is called by theory, 1 mole of substance combusted. So when 2 grams of benzoic acid complete combusted, maksudnya this is called experiment data. So that means they can ask you if the X mole burn, how many energy released. So you can solve the problem by stoichiometry. Right, so we call experiment data. So this all called experiment data. So student, when you look at this question, you need to clarify what is the meaning for the information. If not, right, you just substitute all the information together, you're very confused. Right? So differentiate where is the theory and where is experiment. All right, now how about coffee cup calorimeter? So they say they give you they give you given experiment data as theory. They say this. So this one is called experiment data. Calculate the heat neutralization or reaction means they ask you for 1 mole water, so they release how many kilojoule. So this is they give you experiment, then they ask about theory. So student can find for X mole water how many kilojoule, then for 1 mole water how many kilojoule. So this is the first case. Second case is they give you theory, they ask experiment data. So they can ask you Q or they ask you delta T, or they ask you anything about experiment data. So heat of neutralization for a reaction is a negative 56.2, meaning that you already know 1 mole water, here 1 mole water will release negative 56.2 kilojoule. You already know. So this is called experiment data. So you need to find the final temperature, meaning that you must know what is your Q reaction from the X mole water. So this is called the different theory. This one is called theory, and this one is called experiment. So one student can clarify theory and experiment, so they're easy for you to solve the problem. Okay, now so today I try show you one example to solve the problem for the coffee cup calorimeter. Heat neutralization for the first reaction is a negative 56.2, meaning that this is a 1 mole water release negative 56.2 kilojoule. So 100 ml of 1.5 molar HCl. So this is a HCl. So 100 ml at 1.5 molar and mix with the sodium hydroxide. This is sodium hydroxide. So 100 ml as 1.50 molar. So they mix together, meaning that they mix together in the coffee cup calorimeter. Okay, so now the mass now is 200 ml is equal to 200 gram, because using the density solution 1 gram per liter. Then they give you heat capacity C 15.2 joule per degree Celsius. Why I mention joule? Because sometimes they give you joule, sometimes they give you kilojoule. So student must very alert the unit. Then they give you T initial equals to the 23.2 degrees Celsius. If initial is different, you just average. Okay, now they ask about T final. Okay, first one, student must understand how about the heat transfer. Okay, so heat released by reaction is equal to heat absorbed by. Okay, so since they give you heat capacity and you know the mass of solution, that means heat absorbed by the solution and the calorimeter. Okay, so that means the Q equals to the MC delta T, or negative Q or plus C delta T. So M is a mass of C, and then C is a 4.18. So usually 4.18 you will refer to your front page of the exam paper, they will give you. So joule per degree Celsius and delta T, and C is a 15.2 joule per degree Celsius delta T. So why I mention unit here, because I want to make sure here is a joule and here is a joule. I must make sure the unit is tally. Now to solve the problem delta T, right? So I must know the value of the Q. Okay, student, may I substitute this value in your Q? Right, you must think about that. So the answer is cannot, because that one is for 1 mole water, but the reaction now is not 1 mole water release. Right. So you must very clarify what's meaning by the 56.2. This one according theory. So what you should do now is you need to know how many mole for water. So mole, you need to calculate the mole for NaOH by using the MV over 1000. M is a 1.5, 1.5, and volume 100 ml per 1000. So you get the answer is 0.15. Okay, 0.15 mole, and the mole for the HCl also MV over 1000, you get 0.15 mole. So the ratio here is 1, 1. The ratio is 0.15, 0.15. That means no limiting reactants. If I got limiting reactant, you need to determine it. So that means I can using the NaOH, 1 more NaOH, release 1 more of the H2O. So 0.15 more NaOH. So it's equals to 0.15 more H2O. So now you can compare the state here. 1 more H2O release negative 56.2 kilojoule. So for 0.15 more H2O, so how many? So my answer is negative 8.43 kilojoule. Okay, class, this is a kilo. Joule, here is a joule. So make sure you change to the joule before you do any calculation. So that's why we call unit is very important here. So to substitute the Q, right, negative, negative, you can cancel. So you get your answer here is 8430 joule. So I already cancel negative. So that means you solve the problem. 8430 joule equals to the 851.2 delta T. Then you get your delta T equals to the 9. Okay, so you get answer 9.9. Then delta T equals to T final minus T initial. You get the answer for T final is a 33.1 degrees Celsius. So I calculate delta T so that student very reduce the careless mistake happen. Okay, so that's why you get the answer. All right, so this is for the one example for calorimeter. Now I proceed to the chapter 8.3. Okay, 8.3, right? Okay, so the solution process. When student, you know, the question will ask the solution process is when they give you the enthalpy solution, when they give you hydration, when they give you lattice energy, they mean they ask about the solution process. What is the dissolution process? Actually is equals to delta H solution. Yeah, so that means 1 mole of the ionic solid dissolved in a very dilute solution to form the aqueous solution. Okay, example here is this is NaCl solid. Then they dissolve in water to form the ions, Na plus ions, aqueous, and Cl minus aqueous. That means this is a water, and this is a Cl minus, and this is a Na plus, this is a water. So they already surrounded by water. This is what we call delta H solution. Macam you letak garam, letak dalam air. So garam akan pecah dari ion yang dikering oleh air. Itu maksud delta H solution. So this is a general idea. NaCl to form Na plus aqueous. Tapi actually, like what happened behind the equation is the first one, NaCl will breaking become Na plus gases and Cl minus gas first. Okay, so so this one is we call lattice energy dissociation. Okay, so lattice energy divided by 2. Okay, I proceed to next slide first. Lattice energy divided by 2. One is a lattice energy formation, where is called negative. You form the solid, so solid is very stable. Usually you release the energy. So what is the lattice energy dissociate here? This is a solid, right? You spread it, or you spread it become the ion. This is what I call dissociate. Pecahkan lattice energy. So you pecahkan lattice energy, you perlukan tenaga. That's why the delta H is a positive. Okay, let's say lah rumah kamu garam dah lama tak guna. So, tiba-tiba nak gunakan dia keras. So, you nak jadi pecah jadi ion, you kena ketuk dia kan. So, ketukan is require the energy. That's why lattice energy dissociation is a positive value. So, you can follow my Insta. I got one video about this one. Right, so now, so today, kita from the solid to gas ions, that's why we call lattice energy dissociation, or another meaning, the lattice must in positive value. Okay, commonly, right, in the question, right, lattice energy usually they give you negative value. Usually they give you negative value. So how will become positive value? So I put negative lattice so that negative times negative become positive. So that's why we change to positive. And then the second part is a gas. How to become the aqueous, we call hydration. So where is the overall? Overall is a delta H solution equals to the lattice energy negative and sum of delta H hydration. Then you get the answer. Yeah, it's a 4 kilojoule per mole. Okay, so how you remember? So contain three phase, solid, aqueous, and gas. Atas is a Selangor or anything lah. And here is a plus lattice, positive lattice, and the H is anything. You can remember lah, Selangor hostel ke Selangor hospital, anything lah. So you must remember this is called dissolution process. Okay, come student, we try one example about dissolution process. Using the following data, construct energy cycle to calculate enthalpy change of solution of CaF2. So how you know the question will ask you this solution process. First one, energy change solution. Second one, lattice, hydration for calcium ion, and hydration for fluoride. So the three adik-beradik, solution, lattice, and hydration. So that means that you come up with the energy cycle, the tiga adik-beradik, solid, aqueous, gas. Okay, come we try together. Okay, first one, solid. Bayangkan garam di luar kamu, garam. Okay, so pecah, larut dalam air. So pecah Ca2 plus, aqueous, dah basah dah. So plus the F minus aqueous. So balancekan dia. You must balance on your right side because definition is referred to 1 mole. So 1 Ca, F is a 2F. So label here delta H of delta H solution, you don't know. Alright, this is the first step. Okay, second step, just now I say ada tiga adik-beradik, mesti ada tiga phase, solid, aqueous, and gas. So yang lain tu mesti gas. So become the Ca2 plus gas and plus the 2F minus gas. Okay, so you can see delta lattice energy usually they give you negative, but this one ialah salt become gas. You kena ambil hammer ketuk dia. So dia adalah lattice energy dissociation, or another meaning positive lattice. So that's why here negative lattice energy so equals to negative 2640. So you get answer positive 2640 kilojoule. Okay, now settle for lattice. Now gas to aqueous for hydration calcium ion. For hydration, right, sometimes they just give you hydration or calcium fluoride. So you just draw one arrow. But they spread it like ion, calcium, and fluoride ion. That means you need to draw two arrows. So this one I can label delta H hydration equals to negative 1560 kilojoule. And this one is delta H hydration negative 457 kilojoule. Okay, class. This one, 2 more and 2 more. Hydration refer to 1 more. That means this one you must times 2. So this one is 2 delta H hydration. Right, okay. So now after you solve it, where is the overall? Here. So you can write the formula first. F minus. So you can substitute the value. Okay, so at the end you get the answer is positive 166 kilojoule per mole. Since this is a specific term, so that means you must give me the answer in the kilojoule per mole. Right, so this is the enthalpy of the solution where it involves the ratio 1:2. So students, make sure you balance it. If NaCl okay lah, 1:1. If a CaF2 is a 1:2. So be careful about this type of the question. Alright, so how you get the mark, right? Actually, the marking is I just general only. Let's say this one equation, right? Student must write the complete equation and label the delta H. We call one, right? And here is the second, right? Label the delta lattice and include the product written okay, balance, phase other, label delta E other, then one right. And here and so on, one right. So make sure this chapter, right, phase compulsory, phase must label. Don't just simply write. Okay. Right. So okay, this is for the tiga adik-beradik, the solution process, lattice, hydration, and solution. Alright, okay, now we go to the next one. Just now tiga adik-beradik, right? Now is 1, 2, 3, 4, 5. Okay, sorry, ada pembetulan. This one I call summation. 1, 2, 3, 4, 5. Okay, this one I call 5 adik-beradik. So 5 adik-beradik, right, is involve atomization or sometimes they give you sublimation. Okay, kenapa ada sublimation? Because potassium solid become the potassium gas, right? This one also can call delta H atomization. This one also can call delta H sublimation. Walaupun tak pernah belajar, tapi at least you know. Sublimation is solid to gas. Second one is enthalpy formation. Then IE, EA, lattice. So once they give you the 5 adik-beradik ni, so they ask about Born-Haber cycle. So to construct the Born-Haber cycle, divide by two methods. First one is energy cycle diagram. Second one is energy level diagram. So if the question didn't mention anything, I more encourage you draw energy cycle diagram. Okay, so now I summarize already the process. So, okay. So first one is this one is ionic. Okay, wait, I change the color. Okay, this is an ionic compound, and this is a element. Okay, so element usually this is a metal, and usually this is a non-metal. And this is a delta H formation and refer to 1 mole of the substance form. So that's why here is a 1 mole, 1 times 1K, 1K. 1 times 1 Cl, 1 Cl. So that's why here must become 1 Cl. How to become 1 Cl? 1 over 2 times Cl2. Because element for Cl is a Cl2, not Cl, Cl2. That's why half times 2 become 1 Cl. Right, next one, metal will undergo the atomization to form the gases. After that, they form the positive ion, so you're using IE. Now, non-metal will undergo atomization also to form the gases atom. Then they will accept the electron to form the anion, we call electron affinity. So then the gases ion combine will form lattice. So this is what we call process of the Born-Haber cycle. Where is the overall? Overall is delta H formation equals to all sum together. So no matter how they construct, you must find where is the overall first. Right, so second one is energy cycle, energy level diagram. So where is you must label enthalpy. So here is the overall. So up to you. You can solve the atomization first, then IEEA or up to you. So as long as out is positive and down is negative. Now, so this is the overall equals to sum of the all sum together. No matter if they ask you structure question, right? The important penting you cari where is your formation, because this is the overall and sum of other. Okay, so you must learn how to construct and you must learn how to answer the structure. Let's say they ask you, equation ni apa nama dia? Okay, something else. Now today I will introduce you, we refresh memory again, how to calculate the lattice energy for calcium chloride. Okay, so student you can check, formation, EA, atomization, second IE, first IE, summation, ada tiga adik-beradik, this one must Born-Haber cycle. So now I will construct the Born-Haber cycle first, how we can construct together. Okay, now, so, okay, highlight pen. Okay, now, usually I teach my students start with 2 steps first. Okay, what is the first step? The first step is formation. So I will write the formation first. So formation is 1 mole of the substance formed by its element. Element for calcium is a calcium in solid, and element for Cl is a acid in the Cl2 gas. So wait, just now I said 1 mole of the substance form, right? Here is a 1 mole. Already kunci, that fixed. Here is a 1 mole. So 1 calcium, yes, betul. 1 calcium. 1 times Cl2. So that means got 2 Cl. Is it here 2 Cl? Yes. So this is what I mean by differentiation. Right, so then how about the next step? Saya nak ajar. Okay, the next step I will teach student using draw the lattice first. So for lattice energy, okay, you can label first, delta H of formation, negative 795 kilojoule. You can left answer kilojoule first, at the end baru summarize the unit. So here is a lattice energy. Okay, so lattice energy is a calcium chloride formed by is a gaseous ion. So gaseous ion, Ca is a Ca2 plus, and ion is a Cl minus gas. Here is a 2. So make sure you balance 2 Cl, 2 Cl. So 1 Ca, 1 Ca. What's the purpose? I start with these 2 equations because if you start with calcium solid, right, at the end of process, make sure you achieve Ca2 plus gas. Kalau you tak dapat Ca2 plus gas, means something wrong. Ataupun Cl2 gas, at the end you must make sure dapat 2 Cl minus gas. Kalau tak dapat, means something wrong in the process. This method like counter check lah. So what is your target? Yeah, so 2 days more to go for sitting for chemistry. So what is your target for chemistry? You must start tonight. So first one, dah settle. Next we go to the atomization, calcium gas. So it's a enthalpy of atomization. Don't have, but got summation is the same meaning. So it's a positive 121 kilojoule. Okay, settle the equation number 2. Equation number 3 is a first IE. So IE number first is a form Ca plus gas. So you call IE1 equals to positive 589.5 kilojoule. And then write Ca plus to Ca2 plus is IE2 equals to the positive 1145 kilojoule. So then you know achieve, okay, Ca plus to Ca2 plus, that means selamat lah. So that's why I start with lattice. Now, how about non-metal? Non-metal, right? So you will form the gaseous atom. Gaseous atom. Okay, this one done. This one settled. Now I will study about this atomization of a chlorine. According to theory, is a 1 mole of the gaseous atom formed by its element. Element is a Cl2. 1 mole sudah kunci di sini. 1 mole. 1. But 1 sudah kunci 1. Tapi here is a 2. How I make it 1? That's why I letak setengah Cl2. So, soalan ini ialah Cl2 gas to form Cl gas. Okay, so here sudah 1 mole. 1 times 2, 2. That means here is a 2. Okay, how you make it this equation become 2Cl? You're gonna darab 2. So darab 2, setengah darab 2, 1. 1 darab 2, 2. That's why when you times 2, the value also times 2. So that's why this here will apply the definition. So delta HA equals to positive 121.4 kilojoule times 2. Okay, next one, 2Cl to 2Cl minus. I think you can see 2Cl, you will form 2Cl minus. If you left answer in Cl gas, you can't get a 2Cl minus, so you know something wrong. So that's why I counter check. This one I call EA. So definition of the EA is 1 more Cl gas, except 1 electron becomes Cl minus gas, 1 more. But here is you require 2 Cl become 2 Cl minus. What you should do? So you need to EA. So the answer is EA. So EA equals to the negative 349 kilojoule times 2. This is the reason times 2. All right. So so settle. So at the end, student can calculate your overall delta H formation equals to delta HA for calcium and plus the IE1 plus the IE2 and plus the delta HA for the Cl2. You can write 2 here also can. So next is EA and then plus lattice energy. Okay, so that's why I mentioned overall is very important. So student, you can do it yourself. I give you the final answer. So the final answer, lattice energy equals to negative 2195.3 kilojoule per mole, because they mentioned this is a specific name, lattice, that's why kilojoule per mole. Okay, so before I proceed to next slide, students, so I just want to mention with you to write the equation, right? How they write the mark is this process other phase, return other phase, product, balance, delta HA label, nilai label, get one right. So they will total all the right, then give you the mark. So let's say lah, so sini pun dapat one right. Okay katakan you tak tulis solid kan, so you akan hilang 2 right. So tu cara dia marking. So pelajar, if you construct, make sure you label anything. Okay, so this one for lattice. Okay, so I think students very scary about thermochemistry, but today I cover a little bit the examples, hopefully help you to understand the concept and then reduce the careless mistake. So before I pass, I go to, all right, so after we finish thermo, right, I will go to electro. For electrochemistry, I'll give you the note you can refer. Yeah, you can do your summary, but today I just more go to the electrolysis. Okay, electrolysis are divided by 3 types. First is molten, concentrated, or aqueous. Another one is a dilute. I just explain a little bit about the concentrated aqueous or aqueous solution. For now, it's AgCl, right? And not, you will form Cl minus and H2O. Sorry, I changed my pen first. Okay, now, so as you know, once the AgCl, right, you will form the anode is a Cl minus and H2O. Ingat macam ni je, anion go to anode. So Cl minus go to anode. Cation go to cathode. So Ag plus will go to H2O. Ag plus and H2O mix together because this is concentrated or this aqueous side, they contain the water. So if the ion with higher concentration will be discharged first, example, if the halide Cl minus I minus F Br minus side, so you undergo the process of you choose undergo the process oxidation. So when the Cl minus and the water, right, at the end Cl minus will choose to undergo oxidation. So sebab kita anggap Cl minus dia punya kepekatan cukup, so dia boleh undergo oxidation compare dengan water. So I minus boleh, Br minus boleh, tapi F minus tak boleh. Okay, next part is a metal part. Metal part, right? Kalau you build metal is aurum, silver, copper, chromium, platinum, cadmium, right? It's not the bukan group 1, bukan group 2, bukan group 30, right? So the inner half cell is more positive than water, they more easy reduce. Automatic will choose the Ag+. This is one example. Second example is sodium sulfate, right? Sodium sulfate N ion go to anode, so sulfate ion and water. So siapa akan menang? We'll choose which one. So sulfate ion is a category common also anion like sulfate ion, carbonate, like NO3 minus, phosphate ion. So they cannot be oxidized. Kenapa? Sebab the central atom, sulfur, carbon, nitrogen, phosphorus ni already highest oxidation state. As you know, oxidation is oxidation number meningkat, tapi oxidation number here already maximum. They cannot be oxidized. That's why once you see oxo and ion, apa maksud oxide ion ialah ion yang oksigen tu banyak tu oxide ion. So jangan pilih dia. So siapa akan menang? Yes, answer is H2O. Okay, next one is Na plus and H2O. If Na plus come from group 1 and or group 2 or the Al, right? Usually inner half cell is more negative, so they're very hard to reduce. So maka Na plus won't be choose. You will choose the water to undergo a reduction. Alright, okay, so this one general only. Now we proceed to dilute solution. Dilute solution, whatever like dilute HCl or dilute anything lah, they must undergo process of oxidation for the oxygen, produce oxygen and produce hydrogen. So now class, I teach you how to remember or write the equation. Anode is an oxidation process, will produce oxygen. Sometimes we will confuse oxygen ke hydrogen. Okay, I teach you oxidation produce oxygen. How to write equation? Are you using this Ia orange acid? Okay, Ia is a H2O. Orange is O2, bukan oxygen O2. Sorry. Orange is oxygen, sorry. Acid is meaning by H+. Then oxidation ialah oil rich, oxidation lost electron. So electron is sebelah kanan. Tu cara dia. Then kita akan balancekan dia. Let's say here 2. Yes, so here 4, here 4. Done? So this is the equation for the anode. Okay. How about cathode pula? Cathode confirm reduction lah, because opposite. Then apakah produk dia? Mestilah hydrogen. Oxidation, oxygen. So reduction mestilah hydrogen gas. So how to write equation? I will teach you the tips is air hitam berbase. Kan sekarang hitam kan cincau kan sangat famous now. So air H2O. Hitam now is H2 lah. Bukan hitam lah. Base is stand for OH minus. So as you know, reduction is gain electron, dapat electron. So electron mesti di sebelah kiri. So we'll balancekan dia 2, 2. Betul? So here 2. Dah balance. So why I teach you this method, right? Because this equation will help you solve the problem Faraday law. Kalau anda tak mampu nak tulis equation yang balance, so memang tak dapat solve the problem. Alright, so this is the way you can get the tips how to remember the equation. So the last one, I will show you one example how to do calculation. In an electrolysis or experiment, the current 3 ampere flow through an aqueous solution. So for 4 hour STP, calculate the volume of gas collected. So oxygen gas. So Na2SO4 produce Na plus H2O. This one is a cathode. And anode is a SO4 2 minus H2O anode. This is also, so water dipilih, so produce oxygen. So that's why the answer is on the anode. Okay, so you write the equation first and kita tulis ni. Okay, equation ini ialah very important. Here is cari ini. Ini maksudnya 4 more electron, 4 Faraday, 4 times 96500 coulomb equals to 1 more. So then from the Okay, from the calculation, student can calculate Q equals to I times T. Q equals to 3. T is 4 hour. 4 times 60 and 60 because for Q equals to IT, mesti dalam second. So the answer is 43200 column. Okay, now student tak perlu confuse, you cari column dan mole. So silakan keluarkan stoichiometry ni. 4 times 96500 column equals to 1 mole O2. So 43200 column. So kira lah berapakah mole O2. So you get the answer here is 0.1119 mole O2. Then you can calculate the volume of oxygen gas, STP. Some other STP, room temperature, or maybe they ask you PV equals to nRT, we don't know. So you can calculate 0.1119 mole O2 times the 22.4 liter. So you get the answer is 2.51 liter. So that's why equation happen at end note here is very important to help you construct this one. So that's why I teach you the equation. Right, so that's all for the electrolysis. So I help you, hopefully the sharing here help you to enhance the concept again. So I stop my sharing first. Thank you. I pass to the Miss Ng as a moderator.
Okay, thank you so much for Madam Chia. So, student, you can leave your question, drop in the live chat box. Later, we will answer after the slot number 2 finished. Okay, so now let us welcome. Thank you so much for Madam Chia, and let us welcome Teacher Tang, Madam Tang. Yeah, and also we're going to continue. Okay, we're going to continue with the slot for the organic chemistry. Okay, so Madam Tang, is it ready for it? Okay, so now it's about 10:30.
Oh,
so
yeah.
you may try to leave your question. So we will try to pick the question and then answer for you. Okay, so let us welcome Madam Tang for the chemistry, organic chemistry.
Okay, so hello everyone. So tonight I will cover the organic chemistry. So what I'm going to cover is the chemical properties of organic compounds from hydrocarbons to carboxylic acid. From hydrocarbons to carboxylic acid. So for the hydrocarbons, we know that there are two parts. So alkane and alkene. So I will cover alkane first. So alkane, only one type of reaction in alkane. Okay, not many, only one. Okay, which is free radical substitutions reactions of alkane. So for alkane, so it will be the question number 4. Okay, so the question number 4 will be on alkane and also alkene. So question number 4 on the hydrocarbon. So usually the first part will be the alkane. And how do we know that it's alkane? So usually we refer to the general formula. So if we have the general formula, CnH2n plus 2, that means that the questions is giving you a cyclic alkane. Means that the alkane that is not ring. Okay, so if you have general formula CnH2n, that means that the question is giving you cyclic alkane. Again, alkane only undergo one type of reaction, which is free radical substitutions reaction. So what is free radical substitutions reaction? So remember, for alkane to undergo free radical substitutions reaction, it requires halogen with the presence of sunlight, or sometimes they just write UV. Okay, and there in your syllabus, you only learn mono substitution. So whereby only one hydrogen on your alkane, one hydrogen atom of your alkane is being substituted by the halogen atom given. For example, so if they give us compound A, C4H8 contain 3-member ring. So ring, okay, and then reacts with chlorine gas. So this is the halogen. and then in the presence of UV light, the sunlight, to form monochlorinated products. So with the clue that has been given to you, UV light, halogen, you must know that this must be the free radical substitution. So free radical substitutions reaction, only alkane undergo free radical substitutions reaction. Therefore, okay, so we know that this must be alkane. Okay, besides that, by looking at the general formula, so they give us the molecular formula C4H8. So, and then telling you that it is a ring. So means that this must be a cyclic alkane. So remember, cyclic alkane, general formula CnH2n. So C4H8, so the general formula CnH2n. So this must be a cyclic alkane. So, and usually the question will ask you to draw the structure of the product for the free radical substitutions reaction. So how to draw the product? First, you must be able to draw the C4H8 alkane, your cyclic alkane first. And in this question, they're telling you that consists of 3-member ring. So means that it must be a 3-member ring. And then 3-member ring, only 3 carbon, 1, 2, 3. So another one must be the substituent. Okay, so that must be your cyclic alkane. So, and then how to know the product? Again, you learn mono substitution. And remember, in the free radical substitutions reaction, the hydrogen of your alkane is being substituted by halogen. So based on the alkane you draw here, so we need to deduce how many different environment of hydrogen. Like for example, this alkane, we have this is primary halogen. So this one is tertiary halogen. So one substituent, we can cut it half. So can you see that the 2 hydrogen here and the 2 hydrogen here, they are symmetrical. So means that they are the same. So they are secondary hydrogen. So in this alkane, there are 3 different environments of hydrogen. Therefore, the mono substitution will give you 3 different products. Okay, remember, you ganti 1 hydrogen atom. So if ganti at the primary hydrogen, so you will get this product. Okay, remember, chlorine is the halogen atom, 1 atom, ganti 1 hydrogen. Okay, so if substitution occur at the tertiary hydrogen here, then you will get this product. If substitution, mono substitution occur at any of the 4 hydrogen here, salah satu diganti, then you will get this product. Okay, you get 3 different products because you have 3 different environment of hydrogen. And then in recent years, it is quite popular to ask you to draw the most stable intermediate as well. So this is free radical substitutions reaction. So the intermediate must be the free radical, So the most stable intermediate will give you major product. So which of these 3 are the major product? So yeah, this is the major product. Why? It is because substitution at the tertiary hydrogen will give you tertiary free radical intermediate, which is the most stable, and therefore it will give you the major products. Okay, so therefore our intermediate must be the free radical at this position, at this carbon. Okay, so that is your most stable intermediate. So this is a very popular exam question for these recent years. Okay, so from the alkane, you deduce the products and also be able to draw the intermediates. So that is alkane. Then now we move on to alkene. So alkane, one type of reaction only, free radical substitutions reaction. For alkene, only 2 types of reaction, which is electrophilic addition and also oxidative cleavage. And there are 3 chemical tests in alkene: Bayer's test, bromine test, and test with bromine water. For all of these 3 tests, they are all applying addition type of reaction. So again, alkene is usually the second part of question number 4. So how do we know that that particular question is on alkene? So besides it is question number 4, we can also deduce from the general formula. So if from the general formula, molecular formula, we deduce the general formula as CnH2n, that means that we have acyclic alkene. So if we have CnH2n minus 2, then we get cyclic alkene. Okay, so for alkene, so it undergo addition type of reaction. So still remember what is addition type of reaction? So addition type of reaction basically refer to carbon-carbon double bond become single bond. So become single bond like this. Okay, and then must remember for alkene, so addition reaction apply Markovnikov rules. Okay, so how to remember? You just need to remember mak angkat. Okay, so for Markovnikov's rules, so still remember additions of HX into an alkene, the H of the HX will be added to the carbon of the carbon-carbon double bond, which already have more number of hydrogen atoms. Okay, so you just need to remember the H refer to hadiah. So mak angkat love to give hadiah. Okay, so Markovnikov rules. Okay, we know that the alkene, so which has more hydrogen, then when you add HX, the H of the HX will go to the carbon with more hydrogen. Okay, so mak angkat suka bagi hadiah. So this hadiah, so you already have a lot of hadiah. So like for example, this one you have 2, this one you have 1. Okay, so these 2 you already have 2 hadiah. This one you only have 1. Sudah ada banyak hadiah, mak angkat nak bagi hadiah lagi. So when add HX, the HX will go to this carbon because mak angkat even though sudah banyak hadiah, mau bagi hadiah lagi. Okay, so and then for Markovnikov's rule also apply when you adding electrophile to alkene. So when adding electrophile to alkene, the electrophile will be added to the carbon of the carbon-carbon double bond, which already have more hydrogen atoms. Okay, and if you have HBr with peroxide, then you must know that this is anti-Markovnikov rules. So anti-Markovnikov, hydrogen will be added to the carbon of the carbon-carbon double bond with less hydrogen atom. So this one anti-mak angkat. So mak angkat suka bagi hadiah. You sudah ada banyak hadiah, dia mau bagi hadiah lagi. So giving you H again. Okay, but then for anti-Markovnikov, anti-mak angkat. So mak angkat nak bagi hadiah, tapi anti-Markovnikov, so nak bagi hadiah, so dia tak mau bagi kamu dah, dia bagi to another side because it's anti-Markovnikov. So anti-Markovnikov, how do you know it's anti-Markovnikov? You must be careful. It will be peroxide there to indicate that it is anti-Markovnikov rules. Okay, so and then alkene, so just now I told you undergo 2 types of reaction. So the first one, addition. The second one is oxidative cleavage. So what is oxidative cleavage? So we know that alkene carbon-carbon double bond, oxidative cleavage, basically we break the carbon-carbon double bond. So oxidative cleavage, we can use 2 different types of reagent. So if ozonolysis, then our reagent is going to be ozone. So in ozonolysis, when we write the reagent, it must be step 1, ozone, and in the step 2, zinc and water. You must write 1 and 2 to indicate the step 1 and step 2. Okay, and the product for ozonolysis will always be ketone and aldehyde. Okay, so ketone and aldehyde. Okay, so and then oxidative cleavage can also occur if we use hot acidified CmNO4. Okay, so the product, if we are using hot acidified CmNO4, will be ketone, carboxylic acid, or carbon dioxide with water. So if we get carbon dioxide and water, means that the carbon-carbon double bond must be the terminal carbon-carbon double bond. What does it mean? So terminal carbon-carbon double bond means that the carbon-carbon double bond, it must be carbon number 1 and carbon number 2. Okay, in order to give us terminal carbon-carbon double bond. And when oxidative cleavage with hot acidified CmNO4, then this first carbon will give us carbon dioxide. So now we move on to look at the example questions for alkene. So like for this question, so hydrocarbon B, C4H8, react with HBr with the presence of peroxide. So peroxide, so indicate that this must be anti-Markovnikov. Okay, so it's addition reaction but anti-Markovnikov. Okay, so if this is addition reaction, then this must be alkene. So alkene undergo addition. Alkane tak boleh. Alkane free radical substitution. Alkene addition. And you know this is addition. Reagent is for addition. So means that this must be alkene. And beside that, from the molecular formula, we can deduce that the general formula is CnH2n. And this is the general formula for acyclic alkene. So also indicate that this is alkene. Okay, so and then the hydrocarbon B, the alkene, can also react with hydrogen gas. So this one is again another addition reaction. So telling you again, this is alkene. Okay, in the presence of platinum. And then B can also react with hot acidified CmNO4 to produce carbon dioxide and ketone E. So hot acidified CmNO4. So this is alkene, B is alkene, so means that this must be oxidative cleavage. You nak pecahkan the carbon-carbon double bond. Okay, so if we get the long questions like this, so how do we tackle this type of question? So usually I will suggest the students to draw the flow chart first. Okay, so start with our hydrocarbon B. So the first sentence, react with HBr with the presence of peroxide to give us C. And we know that this is additions of alkene follow anti-Markovnikov rules about the peroxide. Okay, and then haven't finished yet our flow chart. So B can also react with hydrogen gas with the presence of platinum catalyst to give us D. So again, this is additions of alkene. So, and then B can also react with hot acidified CmNO4. So again, I told you already, this is oxidative cleavage. You pecahkan carbon-carbon double bond, okay, to give you carbon dioxide and ketone E. Okay, so from this flow chart, then straight away we can deduce where should we start. Okay, so shall we start with C, B, D, or ketone E? Okay, so most students will start with B. So, but I will tell you, don't start with B. Why don't start with B? Because you tak tahu mana carbon-carbon double bond. So if you do not know where is the carbon-carbon double bond, then you shouldn't start with B. Okay, if you start with B, you're not going to get the correct answer. Okay, so where should we start? We should start with E. Okay, so why? Okay, so why? Okay, so it is because, so just now we know that this is oxidative cleavage, produce carbon dioxide. So kalau produce carbon dioxide, I already told you that means that the carbon-carbon double bond must be the terminal carbon-carbon double bond. It must be the carbon number 1 and the carbon number 2. Okay, so when oxidative cleavage, you break the carbon-carbon double bond, the carbon number 1 ini sebab dia terminal carbon, so it is going to be the carbon dioxide. It is going to be the carbon dioxide. Okay, and the carbon number 2, therefore, will be part of the ketone. So total, we have 4 carbon. 1 carbon here, so means that this ketone will have 3 carbon, and it is a ketone. So therefore, we can deduce our E as this. Okay, as this. So this is the carbon number 2. So this is the carbon number 1. So this is the carbon number 2. So remember, total ketone here, we have 3 carbons. So it must be the propanol. Okay, so it must be the propanol. After we get the ketone E and also we know that carbon dioxide, then we can deduce what is our B by putting the carbon dioxide, carbon, and also the carbon in the ketone together. Okay, so how to put them together to give you B? So we know that, okay, so this is carbon number 2. Carbon number 1 is the carbon dioxide, right? Carbon dioxide. Okay, so now we want to put them together to give us B. Remember oxidative cleavage, beside pecah the carbon-carbon double bond, after pecah the carbon-carbon double bond, they will give the carbon, these two carbon, oxygen. So sekarang kita mau cantum balik, we need to remove the oxygen. So remove this oxygen and then we put back the carbon. So we put back the carbon. So here become the carbon number 1. Okay, and then only we put in the hydrogen, and therefore this is our alkene B. Okay, so this is the carbon of your carbon dioxide, and this is your carbon number 2 just now. Okay, so this carbon. Okay, we put them together to give us the alkene. So whenever you have the oxidative cleavage in your questions, alkene question, always start with the product of the oxidative cleavage. Do not start with alkene. Okay, you need to start with the product of the oxidative cleavage in order for you to know where is your carbon-carbon double bond in the alkene. Kalau tak, you are going to get it wrong. Okay, so after we get the alkene, then we can deduce what is our C and what is our D. Okay, so what is our C? So again, this is addition of HBr, but follow anti-Markovnikov rule because of the peroxide. Okay, so remember anti-Markovnikov, so anti-mengangkat. So this carbon, first carbon, we have 2 hydrogen. This carbon only have, we do not have the hydrogen. Okay, so no hydrogen. Okay, so anti-mengangkat nak bagi hadiah. So sekarang anti-mengangkat, so tak mau bagi the carbon yang sudah banyak hydrogen hadiah, so tak akan diberi dah sebab anti mengangkat. So therefore the hydrogen of the HBr will go to this carbon, the carbon number 2. Okay, this carbon. So here is your hydrogen, and then the Br will be added to the first carbon of your alkene. Okay, remember this is addition, therefore the double bond here becomes single bond. Nampak tak? Single bond. Okay, and the H will be added to the carbon that has less hydrogen. Okay, so anti-Markovnikov. And for D, so this is addition again. So the carbon-carbon double bond will become single bond, and then the hydrogen will be added at each side of the carbon. So that is our D. So, and then in recent years, quite popular as well is they give you the product of ozonolysis. Okay, so product of ozonolysis like this, and ask you to deduce the alkene. Okay, so if only having one, so usually oxidative cleavage will give you 2 products. Like for this question, giving you carbon dioxide and ketone. Usually will give you 2 products. But in recent years, they always only give you 1 product. So if giving you 1 product only, then means that your alkene, so your alkene here must be a symmetrical alkene. So what does symmetrical alkene means? So symmetrical alkenes means that, okay, so like for example in this question, so we have 1, 2, 3, 4 carbon. So 4 carbon, so symmetrical alkene bermaksud in this alkene it will have 8 carbon. So if here 4, then the alkene will have 8 carbon. Okay, and where will be the carbon-carbon double bond? So so this oxygen basically I expand it, so I draw it here. So where will be the carbon-carbon double bond of the alkene P? So it will be at the carbon that is the carbon of the carbonyl. So this carbon number 2. Okay, so look at how I draw this alkene. I told you already, it will have 8 carbon. So how do we draw the 8 carbon and where to draw the carbon-carbon double bond? So to draw this first, we draw this carbon chain first. So carbon number 1, CH3. Carbon number 2, so only one carbon. Carbon number 3, CH2, CH3. And this carbon number 2 is the carbon of the carbonyl. So remember, oxidative cleavage, you bottom the carbon-carbon double bond, and then you give the oxygen. So now we want to combine it back. So you need to remove the oxygen first, and that oxygen will become the carbon-carbon double bond. And then this alkene, it has 8 carbon. So another side of it will be symmetrical with this. So means that kalau bawah begini, atas you also ikut je. So CH3 at the second carbon will be the carbon-carbon double bond, and then CH2, CH3. So this is your alkene P. Okay. So how about alkene Q? So I give you another example. So alkene Q. So again, this ozonolysis also giving you one product. So means that this alkene Q is also symmetrical. It's also symmetrical. So and then yang ini 4 carbon. So alkene Q will have 8 carbon. Okay. So where will be the carbon-carbon double bond? So it will be at the carbon of the carbonyl. So this carbon is the one that forming the carbon of the carbonyl. So means that this carbon will be the site where the carbon-carbon double bond form. Okay, so shall we draw the alkene? So again, to draw the alkene, we follow the carbon chain. So CH3, CH2, CH2, CH. So here is the carbon of the carbonyl. So it will be the double bond. So remember, here will be the 8 carbon alkene. So to draw the another side, it is symmetrical. So you need to draw the same carbon chain. Because this is symmetrical, that's why ozonolysis, bottom the carbon-carbon double bond, you will only get one product. You will only get one product. Okay? So in recent years, usually they come out in question number 8. Question number 8, the carbonyl compounds. Okay? So and then now we move and last year they come out in question number 9. Instead of ozonolysis, they ask in terms of oxidative cleavage with hot acidified KMnO4. Okay, so if oxidative cleavage with hot acidified KMnO4, okay, so usually we will get ketone or carboxylic acid. So last year come out carboxylic acid. So but the concept on how to deduce the alkene, it is still the same. So here in the carboxylic acid, we have 4 carbon. So means that the alkene must have 8 carbon. Okay, must have 8 carbon. So how to draw the carbon chain? It is still the same. But so here is your functional group carbon, C double bond O, OH. Okay, so this carbon will be the site where where is the carbon-carbon double bond of your alkene. Okay, so shall we draw the alkene? So still follow the carbon chain. But then at the carbon with the carboxyl group, so it will form the carbon-carbon double bond. Okay, and another side, remember this is symmetrical alkene. So we just copy the bottom one, just like the bottom one. Okay, but this is not complete yet. So can you see that at this carbon, not enough hydrogen? So you just add in the hydrogen. Okay, so basically this is oxidative cleavage. We oxidative cleavage using hot acidified KMnO4. We cut the carbon-carbon double bond and give the oxygen, and we get aldehyde. This is strong oxidizing agent. We cannot stop at aldehyde. It will further oxidize to give you carboxylic acid. Therefore, you get carboxylic acid. Okay. So usually come out in question number 9, but the concept is oxidative cleavage. So now we move on to benzene. So benzene only undergo one type of reaction, okay, which is electrophilic aromatic substitution. So for benzene, usually it will be question number 5. It will be question number 5. So for benzene, how do you know that that particular compound consists of benzene? So if you get a question and the molecular formula with the ratio of carbon to hydrogen almost 1:1, this indicates that that particular compound consists of benzene ring, okay, consists of benzene ring. And then for benzene, it only undergo electrophilic, one type of reaction, electrophilic aromatic substitution. So where the hydrogen of your benzene is being substituted by the electrophile. Like for example, in the halogenation, the halogen ganti the hydrogen to give you halobenzene. Okay, so and then in nitration, the nitronium ion from your nitric acid giving you nitronium ion. Yang ni nitronium ion akan ganti the hydrogen atom. Okay, so and then in the Friedel-Crafts acylation, so is the ethylene ion. So ethylene ion ganti the hydrogen, ganti the hydrogen. So this is the carbon where the bond break. Okay, the bond break. So therefore, it will connect to this carbon. You see? Connect to this carbon. Okay? So, and then the last one is Friedel-Crafts alkylation. So we are going to have usually the carboxylic ion, the electrophile, ganti the hydrogen, ganti the hydrogen. And then can you see that here is the bond break? So means that this carbon is the one that is bonded to the carbon of your benzene ring. Okay, so this carbon and this carbon connect. Okay, and what is the functions of FeBr3, AlCl3, and AlCl3? So they are Lewis acid. Basically, is to increase the polarity of the bond to form stronger electrophile. Okay, so but benzene ring aromatic have extra stability, so perlukan stronger electrophile. Therefore, we need the Lewis acid to increase the polarity of the bond in order to produce stronger electrophile. And then for alkyl benzene, okay, so this is your alkyl benzene. So at the alkyl side chain, nampak tak this alkyl side chain look like alkane. Therefore, the alkyl side chain can also, remember alkane undergo one type of reaction sahaja, iaitu free radical substitutions reaction. Therefore, the alkyl side chain can also undergo free radical substitutions reaction with halogen. Remember the condition, you need the UV light, okay? And then the mono substitutions product, how many depends on how many different environment of hydrogen. Like for this one, kita ada primary hydrogen, they are equivalent, and here tertiary hydrogen. So therefore, we get two mono substituted product. Okay, so kalau ganti one of the hydrogen here, kita dapat product ini. So ganti this hydrogen, we get this product. Okay, and then beside that, the alkyl benzene. So this hydrogen here, we call it as benzylic hydrogen. So alkyl benzene with even one benzylic hydrogen, it can undergo oxidation at the alkyl side chain to give you the product which is benzoic acid. Tidak kisah berapa panjang, berapa besar the alkyl group, your product, as long as there is one benzylic hydrogen, your product will always be benzoic acid. Always be benzoic acid. So this mind map very important because always come out in exam. Okay, so this mind map very important. Okay, summarize the whole chemical reactions of benzene. So and then mechanism for electrophilic aromatic substitutions reactions is also very important. So usually will come out. Okay, so you must remember there are 3 steps. So step number 1, we need to form electrophile. Remember, this is electrophilic aromatic substitution. So we need to get the intermediate electrophile. And remember, benzene ring sangat kuat, so we need strong electrophile. So just now I already told you how to make strong electrophile. So like for example, in the Friedel-Crafts alkylation, our reagent adalah haloalkane. So haloalkane is weak electrophile. How to make it a stronger electrophile? We need the Lewis acid. Okay, so the Lewis acid. So the Lewis acid. So basically, the bond will be formed between the lone pair of the chlorine, the halogen, with the Lewis acid. So to give you polar bond like this. Okay. So and then the carbon halogen bond. So this bond, whether it will break, it depends on what we are getting. Okay, what we are getting. So like for this question, it will break because we are getting secondary carboxylic ion. So if secondary or tertiary carboxylic ion that we are getting, then the carbon halogen bond will break. Okay, but if primary, sorry, it won't break. So your electrophile will be the whole complex. But for this question, sebab kita dapat secondary carboxylic ion, which is relatively stable, therefore the carbon halogen bond will break to give us this carboxylic ion strong electrophile. Okay, and then in the second step, okay, this strong electrophile can react with your benzene. So this is rich, so this is poor. Electron from the rich to poor, okay, to give us a rhenium ion. So can you see that this carbon here only having 3 bonds, therefore it will have the positive charge. Okay, and for a rhenium ion, we can draw the resonance structure because pi electron boleh bergerak. Okay, so when the pi electron bergerak, we will form the double bond here. So because we want to form double bond, so it will move in between, so to give us double bond like this. So and then now this carbon here having 3 bonds, so therefore the positive charge will be here. And then can you see that the pi electrons here can also move to give us double bond here. And then this is the carbon with 3 bonds, therefore will have the positive charge. Okay, so this is a rhenium ion. So you need to have the arrows correct in order to get the marks. So and the last step, basically is removal of proton. So we want to remove the proton here is referring to the hydrogen ion. So kita mau buang hydrogen ion ini. Remember, in the electrophilic aromatic substitution, kita mau ganti the hydrogen. So we want this hydrogen to keluar. Okay, so kita mau ganti tempat dia. Okay, so therefore the AlCl4 minus will go take the hydrogen, and the carbon hydrogen bond will break, will go in between to give us the double bond here. Okay, and we get our byproduct HCl, and then we get back the Lewis acid. So now we move on to look at, sometimes the question can be a synthetic pathway. So they give us starting material benzene, and end up we want to get benzyl chloride. Ask you to outline the synthetic pathway. So how do we outline the synthetic pathway? So from benzene to benzyl chloride. So can you see that in the benzyl chloride kita sudah tambah 1 carbon. So tambah 1 carbon. So remember, the benzene only undergo electrophilic aromatic substitution. In electrophilic aromatic substitution, there are 4 reactions. So which one can give you extra carbon? So it must be Friedel-Crafts alkylation. So give you 1 extra alkyl carbon. So giving you toluene. So means that in order to form benzyl chloride, it need to pass through toluene. Okay, and then from this, what would be our reagent? So kita boleh deduce dari sini. So our reagent must consist of CH3. So remember, so yeah, this is our reagent. So this is the CH3Cl. Remember, in the first step, the Cl, okay, will react with the AlCl3 to give us stronger electrophile. Therefore, the CH3 must connect it to Cl. And then remember, in order to make it stronger electrophile, we need the presence of Lewis acid. And then we get our alkyl benzene. So alkyl benzene, remember, at the, can you see the reaction is occur at the alkyl side chain? So alkyl side chain can undergo two types of reaction, oxidation atau free radical substitutions. So this one giving us benzyl chloride. So halogens ganti the hydrogen. So it must be free radical substitutions reaction. So remember, free radical substitutions reaction, we have two things. We must have the halogen and sunlight or UV light. So that is our reagent. Okay, and then mechanism to outline the formations of toluene. So this is toluene. So how to draw the mechanism? So again, step number one. So we have our haloalkane, but it is not strong enough. So the lone pair will react with AlCl3 to give us complex like this. So can you see that for this one, the carbon halogen bond, this bond will not break. So why not breaking? It is because kalau break, kita akan dapat methyl cation, which is not stable. Methyl cation and also primary carbocation not stable. So they will not break. So because of that, so our electrophile will be the whole complex. Okay, and then in the step number 2, only the carbon halogen bond break. So the pi electron will go attack the carbon, then only break the carbon halogen bond. So electron will go to halogen because halogen more electropositive. Okay, and then this carbon having 3 bonds, so we'll have the positive charge. So this is our uranium ion. So uranium ion will have the resonance structure. So the pi electron boleh bergerak. So to give us pi bond. Okay, and then this carbon sekarang having 3 bonds, so positive charge. So again, the pi electron boleh bergerak. So in between, so that we can get the carbon-carbon double bond. So now this carbon 3 bond, so we'll have the positive charge. Okay, so the arrows must be correct in order to get the marks. Okay. So, and then step number 3, removal of proton. So we want to remove, remember, electrophilic aromatic substitution mau ganti hydrogen ini. So the last step, buang hydrogen ini. So how to buang? We need something to take it. So we use the AlCl4 minus to go take the hydrogen. So, and then the carbon hydrogen bond break, form the carbon-carbon double bond in the product. And our byproduct HCl, and we get back the AlCl3. So done with benzene, then we move on to haloalkane. So haloalkane, 3 types of reaction: nucleophilic substitution, elimination, and insertion to form Grignard reagent. So we shall look at eliminations first. Okay. So for haloalkane, it will be question number 6. Question number 6 on haloalkane. Okay. So and then for general formula, sorry, this is haloalkane. So for acyclic haloalkane, the general formula is CnH2n plus 1x. And for elimination, okay, the reagent must be base in alcohol. So if you see base in alcohol, that must be elimination of haloalkane. Okay, and reflux, so that is elimination. So for example, so given KOH, the base, ethanol alcohol, reflux, so this is eliminations reaction. So what do we eliminate? So this carbon carry the halogen, this is the alpha carbon. On the alpha carbon, kita akan buang halogen. And the carbon next to the alpha carbon, we call them beta carbon. So there are two beta carbon. So on beta carbon, kita buang hydrogen. So if hydrogen being removed from this beta carbon, then we will get the carbon-carbon double bond between here. Okay, so if we remove the hydrogen from this beta carbon, then we are going to get our carbon-carbon double bond here. So in this compound. Okay, so and then how to know which one is the major product? So Says rule. Okay, so in Says rule stated that in elimination reaction, more stable alkene is the more highly substituted alkene, and it will be the major product. Okay, so from here, bulurkan your carbon-carbon double bond. Ada dua kawan carbon, so this is di-substituted. And this one only satu kawan carbon, so mono-substituted. So di-substituted, more highly substituted. Therefore, according to Says rule, it will be the major product. So for Says rule, you hanya perlu ingat emak saya. Emak saya. So for Says rule, okay, elimination Says rule. Okay, so just now addition mak angkat. So addition Markovnikov rule. So emak saya, elimination Says rule. So now we move on to look at the example question. So elimination. So how to know this is elimination? So again, so you can see that we are removing HCl. We are removing HCl. So this is acid. Kita perlu remove. We need to use base to remove it. Okay, we need to use base to remove it. So here we are having base in alcohol. So base in alcohol means that, and this is haloalkane, means that this must be elimination reaction. Okay, so how to draw this? How to do this question? So first we draw the 2-bromo-2-methyl pentane. So this is our 2-bromo-2-methyl pentane. So elimination. So this is our alpha carbon sebab dia ada halogen, pegang halogen. So this is our beta carbon. Okay, so there are 3 beta carbon. But can you see that these 2 beta carbon are the same? So kalau sama, buang the hydrogen will give you same product. Okay, so alpha carbon, we remove halogen. On beta carbon, we remove hydrogen. So if remove from here, then we get double bond here. Okay, so if remove hydrogen from this beta carbon, then we will get the carbon-carbon double bond here. And which one is the major product? So again, elimination. So emak saya. So elimination emak saya. So we need to look at the Says rule. Okay, so Says rule stated that more highly substituted alkene. So this one is tri-substituted, and this one is di-substituted. So more highly substituted will be more stable. So it will be the major product. Therefore, AA is the major product. So this is the major product, and the BB is the minor product. So now we move on to look at how haloalkane can form Grignard reagent. So again, haloalkane will be question number 6. Okay, so to form Grignard reagent, the reagent will be magnesium dry ether. So for example, so haloalkane. So haloalkane. Okay, so magnesium dry ether, nampak magnesium dry ether means that it must be forming the Grignard reagent. So Grignard reagent is insertion type of reaction. Apa maksud insertion? Selit dalam. So selit mana? Antara the carbon and the halogen. So selit ke dalam sini. That's why you get MgCl here. So this is your Grignard reagent. So Grignard reagent is a nucleophile. So this carbon is electron rich, okay? Because magnesium electropositive, derma electron kepada carbon ini. So the Grignard reagent is electron rich, nucleophile. So because of that, Grignard reagent can be used to form other classes of compound. For example, forming alkane. So alkane, so water, to form Grignard reagent, to form alkane, you need to react with water. So basically, so Grignard reagent is partially negatively charged. Therefore, it will take the hydrogen. So to give us the alkane. So also the same thing, Grignard reagent is the nucleophile. So it can also react with carbonyl compound to give us different classes of alcohol. Grignard reagent with methanol. Again, Grignard reagent nucleophile. Surround the carbon of your methanol, of your carbonyl. Buka carbon double bond to the oxygen. So in the second step, kita dapat primary alcohol. Okay, so if the Grignard reagent react with aldehyde, then we get secondary alcohol. Also the same thing, the reaction, the nucleophile Grignard reagent attack the carbon of the carbonyl, buka carbon double bond to the oxygen. Second step, you dapat OH, so you get secondary alcohol. So it can also react with ketone. So react with ketone, giving us tertiary alcohol. Okay, so and then it can also react with carboxylic acid. So all the same thing, Grignard reagent, nucleophile, attack the carbon, buka the carbon double bond to the oxygen. Second step, kita dapat the OH. So we get, if react with carbon dioxide, we will get carboxylic acid. When writing the Grignard reagent react with carbonyl compound or carbon dioxide, it must be two steps. You must write one, your carbonyl compound, two, acid hydrolysis, H2O, common H plus, or you can write H3O plus. Okay, to form carboxylic acid, number one, carbon dioxide, number two, H2O, H2 plus. Okay, H2O, H plus. So this is an example question. So using 2-bromobutane as the starting material, so show how to form Grignard reagent. So to do this question, okay, first we draw the 2-bromobutane first. So remember, to form Grignard reagent, the reagent must be Mg in dry ether, Mg dry ether, and our Grignard reagent selit ke dalam antara carbon dengan halogen to give us the Grignard reagent, Cc. Okay, and then in the second part of the question, the Grignard reagent react with water. So remember, Grignard reagent is nucleophile. So react with water will give us alkane. Okay, so will give us alkane. So again, attack hydrogen, buka, so you get the alkane. So can also react with carbon dioxide followed by acid hydrolysis. If the question say followed by hydrolysis, usually it will be the two step like this. When you write, you must write two steps like this. Okay, so will give us compound Y. So compound Y will be the carboxylic acid. But Grignard reagent react with carbon dioxide followed by acid hydrolysis, bagi kita carboxylic acid. So also the same thing, attack the carbon of your carbon dioxide, buka carbon double bond to the oxygen. Second step, kita dapat OH. So we get the carboxylic acid. So beside coming out in question number 7, it can also come out in question number 9. Okay, number 6, it can also come out in question number 9, being part of the carboxylic acid. So beside that, it can also react with 2-methyl 3-pentanone ketone to give us tertiary alcohol. Also the same thing, nucleophile attack the carbon of your carbonyl, hook up carbon double bond to the oxygen. Second step, giving us OH, so giving us the alcohol. So it can also come out in question number 7 or question number 8, okay, in the carbonyl and also alcohol chapters. Okay, so and another question that is very popular in recent years is they give us the alcohol. So 3-cyclobutyl-2-methylpentanol, they give us the alcohol, ask us to deduce the carbonyl compound and also the Grignard reagent that form the alcohol. So what should we do? So step number 1, you cannot identify dulu what class of alcohol is this. Like for this question, so this alcohol is tertiary alcohol, 3 carbon friends, so tertiary alcohol. So if tertiary alcohol, then you must know that Grignard reagent must react with ketone. Your carbonyl compound must be ketone. And then you need to know mana tempat perlu cut in order to give you the Grignard reagent and also the carbonyl compound. So where to cut? So let me write first. This is carbon number 1, number 2, number 3, number 4, number 5. So where to cut? You need to cut in between the carbon di mana satu carbon ada OH, satu carbon tak ada. Okay, so can you cut between carbon number 1 and carbon number 2? Cannot, because both tak ada OH. So how about carbon number 2 and carbon number 3? Yes, you can cut here because carbon number 3 have the OH, carbon number 2 tak ada. So remember, satu ada, satu tak ada. Okay, so the side that with the OH will be the carbonyl compound. So it will be your ketone. And the side that do not have will be your Grignard reagent. So can you see that this is the tempat that you cut? So means that here is the carbon that will need to be attached to MgCl or MgBr. Okay, so and this part, so this carbon will be the carbon of the carbonyl, so your ketone. Okay, so this is how you do it. And then if they ask you to write synthesis, you need to write in step number 1, step number 2 like this. Okay, equations like this. So just now I already give you one example. So you can do this example. So this is another way of cutting. So I'll skip this because not enough time. So we move on to look at nucleophilic substitution. So haloalkane can also undergo nucleophilic substitution. So how do you know it's nucleophilic substitution? Kalau bukan base in alcohol, bukan Mg dry ether, that means that the rest will be nucleophilic substitution. You just need to find your nucleophile. And then if nucleophilic substitution, you need to know the mechanism, whether it is SN1, SN2. Okay, so for methyl halide, definitely is SN2. For tertiary haloalkane juga dipanggil alkyl halide, it will be SN1. Okay, so for primary alkyl halide, okay, so if straight chain without the branch, so it will be low steric effect, so it will be SN2. If with branch, then the steric effect is high, then it will be SN1. So if a secondary alkyl halide, we need to look at the type of nucleophile. So if strong nucleophile, it will be SN2. Weak nucleophile will be SN1. Okay, so must remember SN1, reactivity towards SN1 depends on the stability of carbocation. Okay, tertiary alkyl halide giving us more stable tertiary carbocation. That's why tertiary alkyl halide or tertiary haloalkane definitely will be SN1. Okay, and then SN2 reactivity depends on steric effect. Methyl halide lower steric effect, therefore definitely SN2. So shall we look at the example question? So if they give us R and S are the isomer with molecular formula ni, nampak ada halogen, definitely haloalkane. So metanolysis of R through SN1 to produce T. So kalau SN1 means that our R definitely is tertiary haloalkane. Okay, so while isomer S react with sodium methoxide to produce U via SN2. So means that sebab ada 5 carbon, so our S definitely is primary haloalkane with low steric effect. So means that no branch. It's just a straight chain, no branch. Okay, so with that, we can deduce what is our R and what is our S already. Okay, so our R, okay, so is tertiary haloalkane. So tertiary haloalkane, so 1, 1, 2, 3, 4, so 5 carbon. So metanolysis means that react with methanol. So this is a nucleophile. So methanol is the nucleophile. So nucleophilic substitution, ganti apa? Ganti the halogen, ganti the halogen. So the halogen come out will take the H. So therefore the product T is this. Okay, so and then our S is the primary haloalkane with low steric effect. So therefore it must be a straight chain with no branch. And then react with sodium methoxide. So sodium methoxide, this is cation, anion. So nucleophile electron rich. So only the anion is the nucleophile. So we'll replace the nucleophilic substitution, ganti the halogen. So ganti the halogen. So this is our product U. Okay, so write the mechanism for T and U. So T is via SN1. So SN1, SN1, one telling us that only one compound species present in the rate determining step. So step number 1 is the rate determining step. Only satu species sahaja ada. Okay, the satu species itu is our haloalkane. So therefore, in step number 1, you only draw your haloalkane because step number 1 is the rate determining step. Okay, slow step. SN1 satu, so you only draw haloalkane. Okay, so in step number 1, so the carbon halogen bond break, giving us carboxylic ion. So when we get the carboxylic ion, so this is tertiary carboxylic ion. Okay, so this is tertiary carboxylic ion. So this step is slow and it is a rate determining step. So after we get the carboxylic ion, then step number 2 is we are having the nucleophile attacking the carboxylic ion. Okay, so this step is fast to give us the protonated product. And then in the step number 3, remember in our product there is no H, so we need to remove this hydrogen. So how to remove it? So we use the methanol. We have no other things, so we can only use methanol, remove this H, and then the bond break, go to oxygen. Go to oxygen sebab oxygen more negative. So this step is also fast. So if SN2, remember just now to form U is SN2. So 2 means that at the rate determining step, the slow step, the first step, slow step, okay, it involves 2 species, your haloalkane and also your nucleophile. In SN2, your the haloalkane you must draw in 3D structure. Okay, and your nucleophile surround the carbon, alpha carbon from the back, and the carbon halogen bond break. Okay, so to give you the transition state, so this is first part is slow rate determining step. Okay, bagi kita transition state. So here partially bond forming, partially bond breaking. That's why we use the dotted. Okay, and then in the transition state, so this one must be the gut like this. It is because this is trigonal bipyramidal. Okay, so and here is 90 degree. Okay, so and then in the SN2, these 3 bonds must be on the same side. Okay, in the haloalkane, it must be on the same side. But in the transition state, so this one tegak begini because here is 90 degree. Okay, and then so the Br coming out as Br minus, so it's fast, and the product, okay, you must show the inversions of the configuration. Bermaksud kat sini 3 bond ini menghala belah kiri. In the product 3 bond ini kena menghala belah kanan. Okay, so 3 bond ini kena menghala belah kanan. Okay, because when nucleophile coming in, causes the umbrella to inverted, okay, menjadi songsang to another side. So that's it for haloalkane. So for hydroxy compound, so basically we have okay, so maybe okay, so for hydroxy compound, so there are 5 reactions. For aliphatic alcohol, 5 reactions. So the first one, acid. So alcohol, aliphatic alcohol is acid. Okay, so acid can react with metal to give us the salt. Okay, so and then the second one is your aliphatic alcohol can be the nucleophile in esterification, and then it can also undergo elimination and also substitution reaction and oxidation. Okay, and the Lucas test to differentiate different classes of alcohol, that is the substitution reaction. Okay, and then for hydroxy compound aromatic alcohol, so only one type of reaction, that is acid. So aromatic alcohol lebih acidic daripada aliphatic alcohol. So therefore it can react with metal and also base. So the product will always be salt. Okay, so shall we have a look at the question? So the cyclohexanol and phenol react with sodium metal. So this is our cyclohexanol react with sodium metal. Remember, this is acid, alcohol acid, dermal hydrogen ion, so giving you the anion. So sodium, when to achieve octet, you need to donate 1 hydrogen ion. One electron to form sodium ion. Okay, and the product basically is the cation combined with the anion to give you the salt. Okay, and then so as phenol, so this is also acid, dermal hydrogen ion bagi kamu anion. So the sodium metal to achieve octet donate the electron, so become sodium ion. So cation anion giving you the salt product. Okay, and then the second part of the question, so phenol can react with NaOH. Okay, only phenol can react with NaOH. Cyclohexanol cannot. So why? Again, I already told you, phenol lebih acidic. So kalau dia lebih acidic, it can also react with base to give you. So this is acid, this is base, acid dermal hydrogen ion. So combined with the cation to give you the salt, and the byproduct water. Okay, so for cyclohexanol, this is aliphatic alcohol. Tak boleh react with base because less acidic. Okay, so you can refer to your notes. Why aromatic alcohol more acidic? Because of the resonance effect can stabilize the conjugate base. So now we move on to look at the esterification. So how to know is esterification? Alcohol react with carboxylic acid. Alcohol and carboxylic acid, that is esterification, and alcohol mesti adalah nucleophile. Okay, so alcohol nucleophile attack the carboxylic acid, carbon of your carboxyl, remove the OH. OH come out, will remove the H. So the product will be the ester. Okay, and usually the questions will ask what is the functions of the H2SO4. So that is the catalyst. And then if substitutions reaction, so hydroxy compound, your aliphatic alcohol substitute will always give you haloalkane. Okay, so like for example, so this question, okay, so your alcohol cannot straight away giving you ether, tak boleh. So you need to change it to haloalkane dulu. Okay, so how can you substitute the OH with Cl? So we can either use PCl3, PCl5, or SOCl2 in pyridine. Okay, and then only we can, so this is all CH3 ganti the Cl. So this is our reagent. Okay, so this one I skip. So, and then Lucas test is to differentiate different classes of alcohol. Basically, it applies substitutions reactions as well. So different classes of alcohol. So different classes of alcohol. Remember alcohol, general formula CnH2n plus 2O. Okay, so this one, C4H10O, match this general formula. So therefore, it is an alcohol. Okay, so there are 3 isomers. So you want to differentiate them. So means that there are different classes. So primary, secondary, and tertiary. So chemical test to differentiate them will be the Lucas test. So for primary alcohol, Lucas reagent is for SN1. Okay, so primary alcohol, difficult to undergo SN1. So even after 10 minutes of heating, you still do not get the product. So therefore, observation, no cloudy solutions form. For secondary alcohol, substitutions reactions can occur. The OH diganti oleh Cl. So this OH replaced by the Cl, so to give you the product, substitutions product. So since the product is formed, so you will see the cloudy solutions form within 5 to 10 minutes. Okay, so for tertiary alcohol, substitutions reactions can also occur. So OH diganti oleh Cl. So you get the product. So since the product is been formed, so we get the cloudy solutions formed immediately. So and then for elimination, so tadi haloalkane eliminate memerlukan the base. So for hydroxy compound aliphatic alcohol elimination, we need acid concentrated H2SO4 heating. So again, this carbon is the alpha carbon sebab mempunyai hydroxyl group. So kawan dia beta carbon. So on the alpha carbon during the elimination, we eliminate OH. Beta carbon, we eliminate the H. So if eliminate the H from this H, then our double bond will be here. So if eliminate the H from this beta carbon, then the double bond will be formed here. Again, elimination, emak saya, so Sazeth rule determine the major products. So, and then for hydroxy compound, so oxidation. So oxidation, so if can be oxidized, so use the, so acidified sodium dichromate is strong oxidizing agent. So if can be oxidized, turns orange, turns to green. So it can be either primary or secondary alcohol. So cannot oxidize, then it will be tertiary alcohol. So if so this is give yellow precipitate when treated with alkaline iodine solution. So that is iodoform test. So if there is yellow precipitate, so means that the alcohol have methyl carbonyl group. Okay. So so I have explained this. So draw the structure of ABC. So just now C is a tertiary alcohol. So tertiary alcohol. So B, so remember B is, it can be primary or secondary, but B will give the yellow precipitate when treated with the iodoform test. So it must have methyl carbonyl group. So this is the methyl carbonyl group. So this part is the methyl carbonyl group. So therefore, B is our secondary alcohol. So A would be our primary alcohol. So iodoform test. So the reagent iodine in alkaline solution. So must remember this is our methyl carbonyl group. So iodoform test, yang ini akan keluar as CH3, your triodomethane. And this is the one that give you the yellow precipitate. And the remaining one will give us this compound, carboxylic ion. Okay, so we see yellow precipitate form. Iodoform test also quite popular recently. Okay, so do need to remember this. Okay, so for carbonyl compound, so 4 types of reaction. So nucleophilic addition, reduction, condensations, and oxidation. Okay, so for carbonyl compound, so example, these are the example questions that can come out. So this is aldehyde. So this is aldehyde menjadi carboxylic acid. So remember, you learn carbonyl compound first, and then only carboxylic acid. Okay, so you start with alcohol. So if there is alcohol, carbonyl to carboxylic acid, this definitely will be oxidation. Kalau balik, then it will be reduction. Okay, so this one is from carbonyl compound become carboxylic acid. Therefore, it's oxidation. So A must be our oxidizing agent. So example, KMnO4, H plus, heat. Okay, and then can you see that this is aldehyde to primary alcohol? So balik sini. So therefore, this is reduction. So C must be our reducing agent. So example, lithium aluminum hydride followed by acid hydrolysis. So for lithium aluminum hydride followed by acid hydrolysis, 2 steps. Mesti tulis 1, 2. Okay, you must write this. Okay, so for E, I already discussed just now. You can deduce what is your E. So for D, so let me rub this off first. So for D, so if you see carbonyl compound react with NH2 followed by anything, okay, it must be condensations reaction. Okay, so in condensations reaction, we remove H2O. And yang lain tu akan carbon je. So yang ini tinggal kan. So it will be CH3, CH2, CH2, CH. So the double bond. So this part tinggal, so N, NH, PH. So this is our D. Okay. So and then from aldehyde to this, I also cover this. So this is aldehyde. So this is our secondary alcohol. Can you see that you add this part? So means that it must be passing through the Grignard reagent. Okay, so aldehyde must be reacting with the Grignard reagent. Okay, and your Grignard reagent, so I give you the answer, must be this. MgBr. Remember, Grignard reagent, we need to write 2 steps. Okay, so this is our B. So, and then sometimes they will ask you to chemical test to differentiate aldehyde and ketone. So how can you differentiate aldehyde and ketone? So you can use tolerance test. So tolerance test basically is oxidation. So aldehyde oxidized become carboxylic acid, but in alkaline condition, you get carboxylic ion. So, and your silver ion be reduced, giving you silver mirror. So observation, silver mirror form. So, and then your ketone cannot be oxidized. So you get no silver mirror forms, okay? Or you can, okay, and then we move on to look at iodoform test. So iodoform test is to detect the presence of methyl carbonyl group. Again, Methyl group ini akan keluar jadi CHI3 and the remaining will be the carboxylic ion. Okay, so since kita ada CHI3 terbentuk, so we see yellow precipitate forms. Okay, so okay, I will skip to. Okay, and then Brady's test. So Brady's test is to test the presence of a carbonyl compound. Okay, presence of carbonyl compound. Like our F here, this is aldehyde. So this is a carbonyl compound. So Brady's test, can you see this is our 2,4-dinitrophenylhydrazine. So this is NH2. So it's a condensation reaction. Condensation reaction remove H2O. Yang selebih punya hanya carbon je. Carbon je. Okay. So and this is the things that give us the orange precipitate. So other classes of compound, like for example alcohol, will not give us a positive result. So we get no orange precipitate forms. So the last part, carboxylic acid. Carboxylic acid, it is more acidic than phenol. So it can react with metal, base, and also metal carbonate actually. And the product will always be salt. And then nucleophilic substitution reaction, basically, this is our carboxylic acid. Apa berlaku? Nucleophile masuk serang carbon ini, tendang keluar the OH. OH keluar will take the H of your nucleophile, just like the esterification. Okay, and reduction, carboxylic acid reduction, reduce will always give us primary alcohol. Okay, so and then for carboxylic acid, very popular question. So always ask us the synthesis. So in our haloalkane, 3 carbon, and then in our carboxylic acid, 4 carbon. So if 3 carbon to 4 carbon, always will pass through the Grignard reagent. So remember, haloalkane, our haloalkane, 2 bromopropane, so form the Grignard reagent, then react with carbon dioxide followed by acid hydrolysis, bagi kita carboxylic acid. So, or it can also pass through nitrile compound. So this is haloalkane. So nucleophilic substitution, nucleophile masuk ganti the halogen, so giving us the nitrile compound followed by hydrolysis, bagi kita the carboxylic acid. Very popular exam question. So basically that's it. So now shall we back to the Miss Jade, moderator, for questions?
Okay, thank you so much. So it's almost 12 o'clock. I think this is the first time we are having the night live stream. Okay, so now we proceed to some Q&A. So maybe it's not much question. So here we have about 2. I pick up the 2 questions. So this is the first one. So and also I invite back Madam Chia as well. Okay, so this is the first question. Okay. How to draw the structure formula? Can we draw it as expanded or condensed structure instead of skeletal structure? Okay. This one, who can answer the question?
You can draw expanded, condensed, or even skeletal structure. Up to you. Okay, so which one you are more comfortable with, you just use it. Okay, you just draw it. Okay, if you are comfortable with expanded, then you draw expanded structure. Condensed, then a skeletal, then skeletal.
Okay, this is the second question. Hi, Madam, I have a question. I have a difficulty in memorizing all the mechanism. Is there any popular mechanism that should be focused more? I always cannot write the whole mechanism during trial set.
Okay, so the popular one definitely will be the benzene, the 4 mechanism, and also the SN1, SN2. Okay, others I don't know. It depends. So the benzene one not very difficult. The 3 steps are actually the same. Okay, the 3 steps. Only the first step, the formations of electrophile, it is different, but the second step and the third step are the same. Okay, so you just need to do a few times, then you can remember it.
Okay, so another question from Muhammad Ikmal. Okay, does H2O H plus same as H3O plus?
Yeah, you can write H3O plus or H2O comma H plus, or sometimes people write H2O slash H plus.
Okay, so I think this is the question that we have. So any add-on or any things from both Madden, okay, regarding the SK025 before we end our section? So Madden
All the
Chia?
best students.
Regarding the Born-Haber cycle, right? Got one student asked the question. So the energy cycle diagram, energy level diagram is in your syllabus. So if we hopefully ask you to draw Born-Haber, I encourage students using the energy cycle, but you must know how to interpret information in energy level diagram. Right. So the last word is this is the last paper already. So spend your time to well prepare. We already prepared for 4 months. So why not spend time 2 days to prepare the final paper? Right. So wish you all the best, students.
Okay, from Madden Tang?
Yeah. All the
Okay.
best. Okay, so you all can do it. Chemistry is not that difficult. You all definitely can do it. Okay.
Okay, so if you have any question, because it's already 11:51, we'll pecah record, eh? Okay, so actually, there is something from Magic Revision channel lecturers or the lecturer would like to share something with you all. Okay, so this is some quote that we think that for this section 2020 those who cannot adjust to change will be swept aside by it, but if you can stay until now, thank you so much and congratulations, you are recognized the changes and react, so for sure we will benefit. And thank you so much, you stay with us until 11:52. So and then we try to recall back, so from our major revision. Okay, so we have the slot from 1st May, okay, for mathematics, Madam Lim, and also me, myself, Miss Jade, and also for biology, Madam Ashima and Mr. Hafizuddin, and also for physics, Mr. Shake, and for today's. So all of us wish all the best, okay, because this is already the last paper. So, and do not forget, take care of yourself. And also we pray that the pandemic, COVID-19, it uh, can be solved, or maybe we can say that hope that it can getting better and pray for our health as well. Okay, so by the end, so if you have any problem, do not forget, okay, to leave your feedback. Okay, so in the group, there is a feedback form, not only for today's slot, for the mathematics, biology, and also physics. You can try to give us some comments, and those comments can help us to improve for next section for your juniors, the coming juniors, to improve their learning skill and matriculation. Okay, so Madam Tang and Madam Cha, do you still have anything to add on? Don't have it? Okay, so if
No.
don't have, then we just end here. And good luck and all the best. See you. Bye.
Bye.